Hi there, welcome to our talk today on Offline First and Online World. My name is Sean Sullivan. I'm the CTO of CBT Nuggets, and I'm joined by my esteemed colleague, Isaac Overacker. Isaac is a software architect and principal engineer on the mobile side of our platform. Today, we invite you to learn a little bit about our product, our customer, and how it is that we offer an offline-focused approach to our mobile applications. The architecture that we built years ago to serve our customer and platform product needs, as well as how we are reaching for MongoDB Realm today to accomplish what it is we're after. But first, I'd like to present you with a little bit of a story. So as long as I've been at CBT Nuggets, the driving forces of our engineering decisions have been developer velocity, product agility, and operational elasticity. This includes the entire stack, not just the app running on a client, but also the metal that's on the servers serving payloads via the network. Now I want to take you back to a hackathon we had a couple years ago with a group of developers, that really represented a cross-section of the stack and the experience and what we were after. So we were looking to build out a new facet to our product and platform. We took about a day or so, and we had this thing up and running, and it was awesome. The services were built, the front-end website part was accomplished. Even the mobile apps had their presentation ready to go, which leads to the question, okay, this is great, this has been a fun hackathon, but what's it going to take to bring this to production? How can we deliver this to our customers? Turning to the mobile developer, I asked that question, and he said, well, that's when things really get hairy here. We have it working great if you're connected to a network, but supporting the offline part of this, man, that's going to take a little bit more work, probably a few more days, and we're going to have to pull in other teams to make this happen. So I'm sure this might sound like a familiar story to you. If your product and engineering team are supporting an offline experience, you've probably wrestled with this. You have something ready to go, but wait, how are we going to make this thing available when you're not connected, when you're offline? So today we're going to address that. How did we initially solve offline support with our CBT Nuggets apps? Where do we find ourselves today? And how did that lead to the adoption of MongoDB Realm into our architecture? But first, let me give you a real quick, brief overview of our product and platform. So CBT Nuggets is first and foremost an on-demand training product where you can, as an IT professional, level up on your skills through streaming video content that's combined with validation. So along the way, you can make sure that you're keeping pace, understanding how those concepts are presented. We also offer practice exams so that you can verify in a larger context that you've learned what you thought you learned, as well as virtual labs. So once you have that knowledge, you can apply it and actually build something really fun, exciting, cool. In addition to that, we provide comprehensive reporting so that you can see what you've done as well as what your teammates have been up to and what you've all accomplished through your learning journey. As far as our customers go, whether you're an IT manager looking to get your team up to speed on the latest networking technologies, or you're an individual that just wants to earn a certification for, say, a given cloud provider, we have you covered. That's what we strive to help you with. Our company's been around for over 20 years. We started off selling a physical product. Then we found ourselves entering the streaming age. In 2014, 2015, we looked at how we were growing as a product, as a team, and what it was going to take to best make that happen and be successful. So that's when we started evolving our architecture and reaching for a microservices architecture pattern, as well as looking at what our apps were and really architecting a new native app platform. At that point in time, we decided to reach for Realm. We felt that Realm would be the best source of truth to manage state on our devices. To achieve better product agility and developer velocity, we started vetting React Native back in 2019. We got really excited about what that could bring for us and really making it a democratic process for all teams to contribute to these apps. Serendipitously, around that same time, we started reassessing how we were accomplishing offline support. We'd built this wonderful system that served us well for so many years, but was there a better way? Kind of pulling from that hackathon anecdote I presented there. How can we build our features, build our product facets, and then bring them to market faster? It really was serendipitous that MongoDB and Realm joined forces, and at the same time, MongoDB Atlas became part of this so that we could present our solutions end-to-end in this very attractive fashion and keep the state of all these devices in sync. So what's unique to our mobile situation here? Well, as a team, we really approach adding features and functionality to our product and platform in a mobile-first way. What that means is we can't let the mobile experience lag behind. If you can do it on the desktop, you should be able to do it on mobile. We really strive to be a product that you can use anywhere, regardless of connectivity. We recognize the fact that our learners train anytime, anywhere, on the go. And the trick here is when you're back at your desk, when you get off that airplane and sit down to get some work done, it should all sync up. It should be a relatively consistent state with what you were doing, say, on that park bench or on that cabin out in the woods. Furthermore, we have to support all these platforms. We recognize that our learners are on many different devices. Therefore, we're building apps that serve iOS, Android, Amazon, and beyond. Now I'm going to kick it over to Isaac, and he can tell you a little bit more about how we build our offline approach starting in 2015.
Thanks, Sean. So we built our mobile apps in 2015 using an offline-first approach. We achieved our initial version of an offline-first architecture using a combination of a homegrown bidirectional sync service, built-in seed data, and direct communication with our REST APIs. As mobile developers, we all understand the pain points of communicating with our backend APIs over the internet. A mobile internet connection tends to vary more than a Wi-Fi or a wired connection, and we have to concern ourselves much more with network failures and latency. Furthermore, the reality of transferring data between different systems means we have to transform and serialize local data to comply with our backend API contracts. Once we get a response from our backend API, we have to write a lot of parsing and transformation code to use this data in the mobile app. Let's take a look at a simple use case, user stats. As a user watches videos on our platform, we keep track of a few key metrics which are surfaced to showcase the user's progress on this dashboard. First, we have validated minutes, which is a representation of correctly answered quiz questions for a particular section of a video. This information comes from the leaderboard domain. Next is hours watched, which is, of course, the total hours of content watched. Next, we have the number of courses completed, which is, of course, the number of courses the user has watched every video in. This comes from the member domain. Lastly, we have the number of videos watched across all courses. This, too, is from the member domain. So we're aggregating data from two different domains and displaying this in a single view. The traditional approach to presenting this data would be to request it as the screen is displayed. Send two requests off to the services responsible for providing these metrics, and show a loading indicator while those requests are in flight. Then parse the JSON response and present the latest data to the user. The problem with this approach is that we don't have anything we can display when the device is offline. We can take this a step further by introducing a caching layer as a fallback if disconnected from the internet. This is great, but it makes the logic slightly more complex. Fetch the latest data if online, otherwise display a cached value from the last time the requests were made. The approach that has been serving us so well over the last 5 years is to introduce Realm as the on-device source of truth for the UI. Rather than reach out to the leaderboard and member services before displaying this data, simply display what's in Realm. Keep Realm up to date, and the UI will stay up to date. The connectivity logic is greatly simplified. Whether the device is online or offline, simply display data from the local Realm database. In summary, the offline approach with a local Realm database consists of two phases. Read data from Realm and display it in the UI. On a background thread, at some predetermined interval, send requests to each of the services. Parse the JSON response and persist that data to Realm. Using Realm notifications, your UI can then react to the database update and display the latest data. This is great, but as we add more domains into the mix, we end up orchestrating a lot of different network calls to keep the Realm database updated. To solve this, we introduced a new domain concerned only with keeping a mobile device up to date and synchronizing offline viewing activity. Now let's go over to Sean to talk about the details of this domain.
Thanks, Isaac. So now that Isaac has mentioned how we're handling things from the mobile app side of things, let's talk more about the service end and how that ties into our microservices architecture I alluded to earlier. So as we looked at all these hundreds of components we have deployed into our infrastructure, and certain pieces need to participate in this whole syncing adventure, we really needed something in the middle that could manage all of this communication. And so we built a sync service. Really, the two constructs that this offers is the ability to poll as well as push. On the polling side, that means the mobile app is going to sit there and on some given cadence, ask the question, has this individual done anything new since this point in time? Conversely, when it comes time to push that information up into, we'll say, the cloud, that device needs to understand, what do I have locally that I've not yet communicated? And so that means managing this state, this stack of local changes that at some given point, when a buffer is full, etc., it needs to flush that and push that via HTTP to the backend. I wanted to offer a very simplified glimpse into what this looks like. So just taking a slice of our architecture here, you have 3 services that hit on specific use cases. So we have a license service, playlist service, leaderboard service. They're all responsible for their own entities, managing those domains, offering an API to access those. The mobile device is responsible, as I mentioned, for polling and pushing. That all comes together in the middle through this sync service. The challenge here is you have this monolithic proxy layer that really requires many services to coordinate and converse through it. We have these access patterns such as, hey, for this user, give me everything that happened since this time, as well as, hey, this person did this a week ago. You need to update your state on the service layer so that you understand that that happened. What this leads to is your services end up offering a certain surface area to facilitate that style of communication appropriately. And so you're adding very authoritative endpoints. For example, you can now time travel on the server side, as well as getting a user since time Y. That can be a lot of data if you're thinking about the last year. If that person, initial sync is obviously a big challenge because somebody downloads your app for the first time. They've done a ton of things on the desktop side. Now when they hook in the mobile app, they have to get all of that year's activity. Whoa, that's a lot of data. Furthermore, because we're doing all this through HTTP, we had not yet fully realized the event-driven architecture that had merged throughout our systems since we built this system. Now I'm going to kick it over to Isaac to talk about the features and communication methods here on the front end.
Thanks, Sean. As alluded to earlier, there are more domains to sync with the on-device realm. Our course catalog is constantly being updated as we release new content. This new content needs to be made available on the user's device in a timely manner. As a user views content on any device, that viewing activity needs to be synchronized to all of their devices, as well as the website. Lastly, when a user creates a playlist on the website, they expect that to be made available on the user's device in a timely manner. So the first feature is unidirectional, keeping the course catalog up to date. To reduce the initial launch burden, we baked in the latest course catalog in the application bundle and use that as a starting point for our Realm database. From there, the device needs to make frequent requests to our catalog REST API to keep the course catalog up to date. The app is responsible for keeping track of the last time that this update happened, as well as sending off any of the network requests, parsing the JSON payloads, and updating the Realm database. The next is perhaps the most important to our business, keeping track of a user's viewing activity, both online and offline. Viewing activity must be synchronized in both directions. On device, it is important to report playback positions at regular intervals in order to record progress. So an in-memory queue is used to ensure that no heartbeats are lost due to intermittent connectivity issues. When viewing fully offline, these heartbeats are written to Realm. When connectivity is restored, any unsynchronized heartbeats are batched up and sent to our sync service for further processing. The sync service is also polled periodically to retrieve new viewing activity that may have occurred on another device. Finally, we have our user-created playlists created on the website. These playlists need to be made available on all of the user's devices. What we've found over several years of working with this approach is that while it's incredibly reliable, it greatly increases the complexity of adding a new feature to our apps. The sync layer, while simpler than orchestrating many different REST API calls on the client, is still quite complex. Furthermore, this work needs to be done on every platform we support. So we have to deal with this complex sync layer multiple times on multiple different platforms. And that's just on the client. We also have to bring in a resource on the server side to perform the tedious work of fetching a time-sliced data set and reconciling a batch of generated data on the client that may have happened while they were offline. As Sean mentioned earlier, we set out to revamp our mobile architecture late last year using React Native to create a single shared codebase for our Android and iOS apps. We decided to take this opportunity to explore a new approach to synchronizing data to and from our new apps using MongoDB Realm's built-in synchronization features. For the last few months, we've been collaborating closely with MongoDB to bring these new features to life. Just like with our homegrown sync architecture, the source of truth for your app's UI state is an on-device Realm database. This improves the resiliency of your application by ensuring that all data has been persisted to disk as a part of the natural flow of the application's data. We can toss out all of our client-side networking and serialization code, as changes to the Realm are synchronized promptly and automatically by Realm Sync. To date, we've eliminated thousands of lines of networking and serialization code. Furthermore, MongoDB Realm provides useful integration points to the rest of our backend systems using serverless functions and events. In our legacy Realm schema, every app install had a single Realm database for all users on that device. This Realm served many purposes. First, it was a temporary cache for all unsynchronized data. Positions within the videos watched while offline, as well as bookmarked timestamps created by the user in downloaded videos. When connected to the internet, this data would be pushed to our sync service in batches to ensure that the offline viewing history could be reflected on the website as well as on other devices. Next up, video and course progress needed to be pulled from our sync service and stored in Realm to accurately show viewing progress that may have been performed on another device. Next, and quite importantly, Realm is responsible for the metadata behind our entire course catalog: course titles, descriptions, trainers, learning paths, videos. All of it's right there on the device. Finally, user preferences are of course stored in the on-device Realm in order to keep track of things like your preferred playback speed, download quality, last sync date, and more. With MongoDB Realm, we quickly realized that we had an opportunity to rethink our Realm schema to take advantage of the built-in syncing capabilities. Our course catalog metadata was split into a fully synchronized Realm consisting of course titles, descriptions, trainers, learning paths, and other pieces of metadata that represent the content on our platform. It is important to note that this single synchronized Realm is shared between all users, so changes to the catalog are synchronized to all devices immediately. On the user side of things, each user is now given their own synchronized Realm to store their progress, their downloaded metadata, preferences, and other user-specific data. This Realm is created on the server side at a path that only that user can access, and it synchronizes seamlessly to any iOS or Android device that they're training on. Now I'm going to hand it over to Sean to talk a little bit about tying this into our microservices architecture.
Thanks, Isaac. So now that Isaac has uncovered how it is that the mobile apps participate in the MongoDB Realm's syncing mechanism, let's talk about how our microservices join the party. So before, we used to have these time-based queries that came from the services through the sync service to the clients. And what that was is communication saying, hey, since this period of time, what has this person done up in the cloud? Well, now those events are getting pushed to the clients, and it's making it there through MongoDB Realm. So it's up to the services to share that information through an event-sourced architecture, and the clients participate really automatically from our end. Furthermore, when stuff happens on the client side that needs to make its way to the services, it's happened unbeknownst to them. Those events flow through MongoDB Realm from the client to the services. Once again, event architecture, event-sourced architecture for the win. So here's what we see with our microservices architecture, taking that same diagram we had before, very simplified, but notice that yellow path. So now we're going from the mobile device to MongoDB Atlas, leveraging serverless functions to put that onto Amazon Kinesis, which we use as our streaming service of choice. That makes its way into the license service, which then can do whatever it needs to with it. Within its domain, it has components that consume those messages, update its source of record, so on and so forth. Furthermore, imagine off to the right there, somebody goes onto their desktop and they do something that's going to hit that license service. Well, now we have stream coming out of the license service to an event processor that will be a Lambda. That makes its way into MongoDB Atlas Realm down to the device. Greatly simplified from our end. So what are the wins here? Well, first and foremost, developer velocity, right? You can now work within your domain. You don't have to touch the sync service thing that some other team might own, or you're going to be troubled with deploying or managing, maintaining. Every single service domain is responsible for joining the MongoDB Atlas and Realm party. They're going to publish and handle events to and from. Furthermore, scaling is something that we don't have to worry about in this game. Operational elasticity is accomplished by offloading the scaling challenges to MongoDB. It's not our problem anymore. We don't have to figure out how this central point of communication between all these devices is going to scale over time as our demand increases, or even, think about these bursts that we talked about. Somebody's offline for a considerable amount of time. They're on a beach, they're in the woods, they're training. That could be a week's worth of events or even more. That's a significant burst of events when it comes down to it. So from a service standpoint, much less code that we have to manage. We can throw out that entire sync service and just leverage MongoDB Realm to accomplish that for us. On the client, we're no longer concerned with making requests to services, parsing the JSON, updating Realm manually, all these things, all that logic that Isaac mentioned around, filling up a buffer, making sure we're flushing it, just having all that overload, all that overhead that we have to do on the client side. We're simply reading from Realm. We're displaying the UI. Realm Sync is handling the rest for us. It allows us as a team to add value more than building systems to make all this happen. So let's get down to the takeaways here, really. Before MongoDB Realm was just a local-only source of truth that was requiring much wiring to arrive to being that local source. You had to do all the serialization, deserialization, HTTP, be cognizant of connectivity. We don't have to do that anymore. We look at Realm as a full-stack solution. That means less client code, less cognitive overhead of working on our apps. The service layer, as I just mentioned, and just to drive that home, we threw out a service that we had built and had a lot of operational overhead there that just kind of went away. And now we can use our partners in MongoDB to make that possible for us. That's less operational burden. The service teams don't have to deal with that. And once again, we're in this to provide the best learning platform, best learning experience possible to help our customers gain knowledge and skills. And that's what this allows us to focus more on, is how is it that our product and platform can best offer that. In summary, MongoDB Realm is something that we're extremely excited about using full stack within our system and our product. And we're really excited. Thank you for sharing with us in this conversation, this presentation, and we hope you enjoy the rest of the virtual conference here. Thank you very much.